and welcome to our next session at DSS. Our next speaker is Jesus Espino, and he will be talking on running Mattermost on YugabyteDB. Jesus, over to you.
Thank you. Yes, I'm going to be talking about my experience running Mattermost on YugabyteDB. This is interesting because Mattermost is a 10 years old application, so it's really mature application, production ready. So have a lot of code, have a lot of data ready, and having that running in a different database normally is challenging. So, I'm principal engineer at Mattermost, so I've been doing this as an experiment, part of my work there. And first of all, what is Mattermost? Mattermost is a communication platform that is open source. You can run it on-prem, but we have our own cloud offering. And the specialty of Mattermost is for mission critical system where you really need the stability and security, things that you want to keep running, and you want to be sure that that's not failing. That's where Mattermost shine. And our focus always is in stability and security. So why a distributed database for Mattermost? Well, a distributed database in general aligns very well with Mattermost focus. So stability is one of the big things that a distributed database can provide. Also, the potential of high scalability. That's something that we really appreciate for sure. And geopartitioning is something that can be really useful for certain customers. So we found that part of distributed databases also really interesting. But more specifically, we are talking about YugabyteDB here. And why YugabyteDB? Well, YugabyteDB is open source, and Mattermost is open source too. So we really like open source. So having an open source database, open source distributed database that we can use is a perfect fit for us. Also, other good reason is that Yugabyte is highly compatible with Postgres. Other thing that we do is we try to be as scalable as possible. So we have to do load testing and verify that everything is working, verify when something is not working or when something is not scaling properly. We need to figure out what is going on. And YugabyteDB have very good metrics. The administration system of the cloud, that was the instance that I used for all these experiment, was really good, really easy to use. So it was a plus for sure. And also they have this cloud hosting service that I use for my my proof of concept or my experiment. And yeah, it works really well. So Yugabyte was a great option for keep working. Well, this is something that is not my first try with Yugabyte. I tried a different distributed database in the past. Like 3 years ago, I tried to run Mattermost on top of a distributed database. I don't going to name it because the result wasn't satisfactory. So it was 3 years ago. So even if I name it, it's software from 3 years ago, not the current status of the project. So I don't think it's fair to give a name and judge that from this difference in time. The changes needed for that experiment with the other distributed database were big. We had to do a lot of changes in a lot of files. Some of them were very specific for the specific distributed database. So we have to decide that, okay, if the database that you are using is Postgres, use this query. But if it's this other database, use this other query. So that introduced a lot of exception and a lot of different queries in for Postgres database, for, in theory, a Postgres-based database. That was a problem, but I did the job. I make it work and keep going with that. End up working, but the problem was the database was collapsing when we start load testing it. We have a very solid load test system in Mattermost, and we are able to generate a lot of realistic synthetic traffic for the system. The problem was with, I think the first test was like for 700 users, 700 concurrent users, everything was collapsing already. I talked with the support team of this database, and the system, they suggest me to change some queries here, some specific way of making the queries and things like that. And we reached the point where we were collapsing at 2,000 users, what is far from the ideal. This graph there is the performance of the P99. You can see that the P99 latencies were over 4 seconds, what is completely unacceptable for our system. So at that point, we didn't keep going and keep optimizing different queries for this database because we didn't see the value on putting so much effort without any certainty that that's going to end up scaling for our workload. So my conclusions, my lessons learned there was distributed databases are hard. They have certain degree of complexity and they have certain restrictions that are not included in something like Postgres. It is not a drop-in replacement. It's not something that you can replace Postgres with that and use it directly. And you need to design your queries and your indexes for the distributed database. So that were my lesson learned 3 years ago before my experiment with Yugabyte. So then, some early this year, I went to a Postgres conference. I met Frank Pachot there, and we were talking about the possibility of running Mattermost on a distributed database, and specifically on Yugabyte in this case. And I shared with him my concerns about the problems with the queries, that I don't want to make so many specific queries, or I don't want to make a lot of indexes tuning for making it work in an acceptable way for Mattermost. I shared my experience, my previous experience, and he said me, don't worry about that. Try Yugabyte. Yugabyte is very compatible with Postgres. The queries are going to, most of the queries are going to work out of the box. So I was doubting about it, but I give it a try. So this was the first thing that I noticed. The changes that I need to do were very small changes that only affects database migrations. And the reason for that database migration to fail, one was because I was configuring the vacuum, the auto vacuum of Postgres in some migrations. And the other one was because we were altering a table, altering 2 columns in the same query. So I only have to split that into different queries, and everything works smoothly. So the amount of changes that I need to make it work was really small. I run it. I start trying it. I start sending messages, creating channels. Everything was working fine. I run the test, the test suite, I run the end-to-end test. Everything was working as expected. I was completely shocked by that, and I was amazed for sure. The next thing that I did was the next thing was to run a load test, and then I had another surprise. That was the database was collapsing again at 2,000 users, and the performance was not even getting stable, and collapsing was getting worse over time. That was a bummer. So both average and P99 was growing over time. And after talking with the support team from Yugabyte, I saw that there were some very weird query plans happening. The reason for they give me a solution for this problem, and the solution doesn't was it wasn't a specific queries, a specific index, or something like that. The solution was run analyze. The reason for that is we were using Postgres compatibility in Yugabyte, and we were using cost-based optimizations, cost-based query planning. And the cost-based query planning in Yugabyte requires to analyze the data time to time. So because I started with a clean database and I didn't have any statistics, the cost-based optimizer was generating query plans basically at random. And after running analyze, the statistical data was updated, and then we have better data for selecting the query plans. And if you go to the results, that is what happened. Then we have all these problem around a lot of load, a lot of latencies, all that stuff. And suddenly I run analyze, and that drops drastically and gets stable in the range of milliseconds, what is pretty amazing, to be honest. I was very happy at this point because I didn't need to change any code, and suddenly everything was working as I expected. The other thing that you can see here is the graphs from the cloud system in Yugabyte. Is the graph about the Yugabyte cloud performance, and you can see there that the CPU after executing the analyze went to 20% or something like that, and the latency is also drops drastically. So is exactly what I expected. Okay, that was great. 2,000 users was working fine. 2,000 users is a relatively small instance in Mattermost. We have way bigger instances than 2,000 users. So I did want to try something bigger. And I figured out that more or less the Yugabyte cloud was able to support around 6,000 users to 8,000 users, something around those lines. So I tried to generate a load test around 6,000 users. The first part of this graph is not related to the load test. The rest of the graph is what is related to the load test. And you can see that the load test is pretty stable, pretty consistent for the P99 and for the average time for API calls and the store calls. The store calls are the functions that wraps the SQL queries. So we have a repository pattern, and we execute the queries inside these store functions. So every time that we call a store call, we measure how much time it takes, and we can see there that the average time it's milliseconds, and the P99 it's maybe around something between 100 and 200 milliseconds. So it's a very good performance. It's very good for what I was looking for. And the other thing is the same graph from the Yugabyte cluster. We can see similar behavior, eaten apps being stable around 50% of CPU usage, 750 requests per second, and the latencies are stable and relatively low. So that's great too. Some lessons learned. Yugabyte can be a drop-in replacement, at least for Mattermost and for our workload. It worked great without any changes. So I didn't need to change anything in the code except the migrations. So it's almost, I would consider that can work great almost without changes. And the other lesson learned is that Yugabyte requires analyze to make smart decisions about the query plans when you are using cost-based optimizer. So yeah, take that into account if you are using that. Then what I did is compare Yugabyte load test against the Mattermost Postgres-based load test. So I run both with the same load and I compare them. The comparison is between Postgres Aurora with 1 node, 2 virtual CPUs, and 16 GB of RAM, and a Yugabyte cluster with 3 nodes, 24 virtual CPUs, each 8 CPUs per node, and 96 GB of RAM, that is 32 GB of RAM per node. That was the configuration of the two clusters, and this was the results. The Yugabyte average store times and P99 times are always over the times of Postgres, and for the same in the same way, the API times are always over the Postgres times. So Yugabyte in general is have a higher latency and it's kind of slower than Postgres. Also, apart from that, I take measures of the application server. The application server have some measures like the number of go routines and things like that. But the reality is the code base is exactly the same. We are using the Postgres library to connect to the database. We are using, everything is the same. So I will expect this to be almost identical, but there are some artifacts that make them different at the beginning. But the last part that is more important is it's consistent and it's similar in both cases. In some cases, Yugabyte takes less go routines and less stack use, but I don't think it's really relevant or it's really meaningful here. Some conclusions about this experiment. Well, Mattermost works and scales on Yugabyte. That's something that's what I was trying to figure out, and I think it's true. I'm able to run Mattermost on Yugabyte, and it's able to scale reasonably well. Yugabyte is very compatible with Postgres. I was really surprised, and I was really glad that YugabyteDB is so compatible with Postgres, because I didn't need to change anything and the queries were working great, and I didn't need to change my queries to make them more comfortable for Yugabyte, things like that. What is Postgres is able to handle more with less resources. That's a fact, at least from this load test. And Yugabyte has high latencies in general. All the previous conclusions are, in my opinion, are expected and are the price to pay for having the benefits of a distributed database. So you have all the benefits of having the data distributed in multiple servers, the stability, the robustness, all that stuff. It requires that your data gets replicated, that your data goes through all the nodes, and whenever you query the data, you have to find the data on the right nodes, things like that. All that takes time, and all that takes some effort from your cluster. So I think it's normal that you have that higher latencies and that extra cost. And that's it. Thank you. If you have any questions or doubt, feel free to reach me out in the comments. Thank you, everybody.